So I warmly welcome you all to the Faculty of Technology, University of Sri Jayawardhanapura. We are going to start Chemistry for Technology lectures. I'm Dr. Suranga Rajapaksha. Before we start lectures, I want you guys to understand very important thing, which is the university education versus school education. When you are at the school, what did you do? You just took all the information provided by your teacher and you memorized it, you studied it, and you didn't have any responsibility to read more material and build your own lecture note, own lesson notes. But when you are in the university system, so there is a major difference compared to the school. During school learning, you used to take information from your teacher and write it down and study. That's the method. We call that method as a teacher-centered learning. The teacher provides all the material you're supposed to study. That is the school system. Okay, so during the school system, the teacher provided all the material you're supposed to study. There's a huge difference when you come to the university. During the university education, what is the lecturer doing? The lecturer is helping students to identify the area he's supposed to learn. Okay, so what is the major difference? In the university education, by means of lectures, right? So in the university, we conduct lectures. During lecture times, the lecturer is trying to help a student to understand the area he's supposed to study. So in the university, the student has the responsibility to find material, taking notes and writing his own lecture notes for the corresponding subject. The lecturer doesn't spend large amount of time compared to the teacher with the students. During the lecture time, the lecture time is very limited. Therefore, the lecturer has to cover large amount of material so that lecturer is basically briefing the subject. But once the course is completed, a student must be an expert of this course. Therefore, a student should learn. She should read more material. A student can find a lot of information when they browse the internet. The knowledge is available. So only way to acquire the knowledge by reading, listening. There are a lot of YouTube videos regarding each subject. So you should be more curious to learn more things about each subject. So that is the major difference of the school learning versus university education. Therefore, so this is the first lecture, and you must be converted to the university system. What is the university system? During the lecture time, the lecturer is providing the guidelines to a student so that students should be able to learn the area. Okay, so during the lecturer providing the guideline so that a student can easily explore the subject area. Okay, so you have a responsibility to study more, study alone, read, listen to subject material. So there are a lot of ebooks available, so you can find a lot of materials when you are going to start the university education. So remember that. Okay, so don't think that the lecturer is providing A to Z information during the lecture. Okay, so that is very important you to understand. So here are the topics we are planning to study. So major topics are atomic structure and periodic table. So before you talk about all the other aspects in chemistry, you should be able to understand the atomic structure and the periodic table. So then we are going to talk about chemical bonding types and molecular structures. And we also going to explore some parts of organic chemistry, not very deep. The level you are going to learn in this course is very low. So you should not expect the level of the local A-level student. So you are learning very lower level of the chemistry, because as a technologist, you just need to know the information to understand the chemistry aspects in each and every subject area. That is the idea. What we are trying to do, we are trying to help you to understand if there is chemistry involved in your specialized area in the future, you should be able to understand it. We are not expecting the level. We are not expecting your level as the same level as chemist. So we are not expecting the level from you similar to the chemist. We helping you to understand chemistry material in your specialized area. So these are the major topics we are going to discuss during our lectures. So I will be conducting the half of lecture sessions. Then Dr. Chami will conducting the rest of the lecture sessions. So there are 2 lecturers involved in this course. Okay, so let's start the atomic structure and periodic table. When we analyze the atomic structure, there are very important parts of the atom. The atom has very important parts. One of the parts of the atom is called the nucleus. So in the center of the atom, we have the nucleus. Then there are some subatomic particles around the nucleus. These are called subatomic particles. So around the nucleus. So basic structure of the atom. So it has a center. We call it as a nucleus. Then it has energy levels like this. There are energy levels. So that is the basic structure. When you are going to talk about the atomic structure, you have a nucleus, then there are energy levels around the nucleus. So there are several theories in order to describe the atomic structure. I'm not going to discuss all these theories. Okay, so basic thing is you need to understand that the atomic structure is consist of nucleus. There is a nucleus in the center of the atom. Then there are energy levels around the nucleus, So this atom is made out of subatomic particles. This atom is made out of subatomic particles, SUB, subatomic particles. Okay, subatomic particles. So what are the subatomic particles? So as I mentioned, let's study the nucleus. Let's study the nucleus. The nucleus consists of two subatomic particles, proton, neutron. The nucleus consists of two subatomic particles, which is proton and neutron. There is another subatomic particle which is available on energy levels. As I mentioned you, there are energy levels around the nucleus. So there is a subatomic particle on the energy levels of the atom. So we call that one as an electron. So therefore, there are three types of subatomic particles in an atom. Proton and neutrons are available in the nucleus. Electron is available in the energy levels around the nucleus. So these are the three subatomic particles. So these are the building blocks of all the atoms. Okay, all the matter existing in the universe. So atom. So let's study each and every subatomic particle. So I'm going to start the discussion with electron. So let's study an electron. Let's try to understand the subatomic particle called electron. Electron, where it is located? Electrons are available on energy cells around the nucleus. Around the nucleus, we have energy cells. On the energy cells, we have electrons. So, subatomic particle electron, we give the simple symbol as E. When we consider the mass of the subatomic particle, when we consider the mass of the electron compared to the neutron and proton, that is the relative mass. When we compare the mass of electron with neutron and proton, you can see that mass of electron is extremely small. Mass of the electron is extremely small. 1 divided by 1836, very small number. Okay, so electron is the lightest subatomic particle in the nucleus. So when we analyze the charge of the electron, we can identify it as a -1. The charge of electron, the charge of one electron in the atom is -1. Okay, -1. So again, electrons are available on energy cells which are around the nucleus. The symbol is E. It is the lightest subatomic particle with negative charge. Then let's focus on subatomic particles available in the nucleus of the atom. So we have neutron and proton. Let's talk about neutron. So symbol is N. Compared to the electron, it is a heavy subatomic particle with no charge. There is no charge of the neutron, but it is heavy. Compared to electron, it is heavy. Neutron is heavier than the electron. Okay, but the charge of the neutron is 0. When we analyze proton, this is the symbol for the proton. Again, compared to the electron, it is heavier subatomic particle with positive charge, positive 1 charge. The charge of one proton is +1, positive charge. So when we compare neutron and proton, you can identify that they have similar mass, right? Relative mass is the same, but neutron is 0 charge, proton is +1 charge. So this is a very important thing you need to understand. So proton, neutrons are available in the nucleus of the atom. Electrons are available in the energy cells around the nucleus. The charge of electron is -1, charge of proton is +1, neutron is neutral. So we talk about two terms in chemistry based on these subatomic particles. In chemistry, we talk about two terms. Those are very important terms. One term is called atomic number. The other one is called mass number. Atomic number and mass number. So these are extremely important things. What is the atomic number? The atomic number is equals to the number of protons in the nucleus. So atomic number is equals to the number of protons in the nucleus. Okay, atomic number is equals to the number of protons in the nucleus. What is the mass number? The mass number is equals to the number of neutron plus number of protons. So at mass number is equals number of neutron plus number of protons. Okay, so when we are going to talk about elements, when we are going to talk about atoms, these are very important terms. Atomic number and mass number. Atomic number is number of protons in the nucleus. Mass number. So mass number is number of neutron plus number of proton in the nucleus, right? That is the total number of neutron and proton in the nucleus is called the mass number. So these are very important terms. So why they are important? So this is called the periodic table. This is the periodic table. And there is a pattern of the periodic table. What is the reason to arrange these elements in this order? there has to be a logic behind the periodic table. So number 1 element is hydrogen, number 2 helium, number 3 element is lithium, number 4 beryllium, boron, carbon, number 7 is nitrogen, number 8 is oxygen, fluorine, neon, likewise. So we need to understand what is the meaning of these arrangement, what are the logic behind the elements arranging in the periodic table. So you can see that there is a number in each and every element. There is a number 1, 2, 3, 4, 5, 6, likewise it's keep going. Okay, what is this number? What is the meaning of this number? What is the meaning of this number? Okay, so this is the atomic number. We call it as the atomic number. So this is the atomic number. Atomic number. In the periodic table, we can find atomic number and how these elements are arranged in the periodic table. How these elements are arranged in the periodic table. What is the basis then? They have used the atomic number in order to arrange the elements in the periodic table. Okay, they have used atomic number in order to arrange the periodic table. So atomic number, in other words, atomic number is equals to the number of protons. So atomic number is equals to the number of protons. For an example, let's take the first element, which is the hydrogen. Atomic number is 1. Atomic number is 1. So atomic number is 1. So what is the meaning of that? The hydrogen element, in the nucleus of the hydrogen element, has only 1 proton. Only 1 proton. Clear? If I take another example, let's see krypton. This is the krypton. Number is 36. What is the 36? 36 is the, right, krypton. 36 is the atomic number. 36 is the atomic number. In other words, number of protons of the krypton is 36. There are 36 protons are available in the nucleus of the krypton. So therefore, you need to understand that when number of protons are going to change, what you are going to change? You are going to change the element. That is the important thing. If it is hydrogen element, example, I'm going to take an example. If you are going to talk about hydrogen element, how many protons are available in the nucleus? How we know? Based on the atomic number, we know that atomic number is equals to the number of protons. Therefore, we can identify that hydrogen's atomic number is number 1. Therefore, hydrogen has 1 proton in the nucleus. Let's compare hydrogen and helium. Hydrogen and helium. So, hydrogen has only 1 proton. Helium atomic number. Helium's atomic number is number 2. Therefore, what we can say about the number of protons in helium is helium has 2 protons in the nucleus. Helium has 2 protons in the nucleus. As a result of that, we never find hydrogen with 2 protons. Everyone understanding what I'm saying? If an element has 2 protons in the nucleus, there is an unknown elements A. And the information we are given, which says that the element A has only 2 protons. Element A has only 2 protons. Where the protons are located? In the nucleus. So element A is unknown. Therefore, we are given information regarding the element A, which is the number of protons in the nucleus, which is number 2. So there are 2 protons in the element. So if you are going to identify the element A, right? So you should not be thinking that whether hydrogen has 2 protons. Why? You know that hydrogen has only 1 proton. If there is 2 protons, then it is helium. So this is the important thing. There are no 2 elements with same atomic number. What I say? There are no 2 elements or more elements with same atomic number. Okay, so there are no any nucleus, 2 nucleus with same number of proton in the nucleus. If number of protons in the nucleus is going to change, then the element is going to change. That is the important thing. Clear? So that's why hydrogen, helium, lithium, we can identify various types of elements in the periodic table with different atomic numbers. If the atomic number is the same, let's take an example. I'm going to take an example. So we have 2 unknown elements, element A, element B. The number of protons of each element, element A has 24. Number of protons in the nucleus of element A is 24. Number of protons in the element B also 24. So both unknown element has same number of, both unknown element have same number of protons. Both unknown elements have same number of protons. So proton number is called the atomic number. Therefore, what you can say about element A and B, they are identical elements. Element A and B are identical. In other words, element A, element B, we are talking about the same element. Okay, so let's slightly change that question. Suppose number of protons in the element B is 84. Okay, so number of protons in A is 24, number of protons of B is 84. So now what you can say? So element A and B has different number of protons. Therefore, we are talking about two elements here. A and B are not the same elements. So it's very important you to understand this. So atomic number is the number of protons in the nucleus. In other words, atomic number is the key factor to arrange elements in the periodic table. Elements in the periodic table. Here is the periodic table. Okay, so that one you need to understand. So when we talk about these atomic numbers, mass numbers, we can find isotopes. There is a word in chemistry, we call it as isotopes. Okay, there is a word in the chemistry, what we call isotopes. Isotopes. What are the isotopes? What is the meaning of the isotopes? So I have given you 3 atoms. I have given you 3 atoms. So when we give a symbol of the atom, there are numbers here and numbers there. When we give a symbol of the atom. So the top number, right? So I will give a simple, and suppose your element is A. So there is a number here. This is how you present an element. There is a number here. So what is the meaning of this number? It is the mass number. Mass number. And what is the meaning of this number? It is the atomic number. Atomic number. So mass number is equals to the number of protons plus number of neutrons. Atomic number is equals to the number of protons of the element. Okay, so mass number and the atomic number. So let's analyze these 3 atoms. Let's analyze these 3 atoms. So this is the atomic symbol. So let's try to analyze the atomic symbol. First one. This number is the atomic number. The number in the bottom is called the atomic number. And the number on the top of the symbol is called the mass number. I have already introduced you what is the mass number, what is the atomic number. So let's compare atomic number and mass number of each and every atom available here. So I'm just circling the mass number. So first atom, mass number is 1. Second atom, mass number is 2. Third atom, mass number is 3. Now I'm going to circle atomic number. First one, atomic number 1. Second one, atomic number 1. Third one, atomic number 1. So what you can say, the atomic number of these 3 elements are the same. In other words, number of protons in the nucleus of the element is the same. So if the atomic number is the same, then what you can say? We are talking about the same element. We are talking about the same element. So if you browse the element in the periodic table, you can identify that hydrogen has the atomic number 1. So therefore, we are talking about the same element, which is hydrogen. However, we can identify that the mass number is different. Mass number is different. In other words, what is the mass number? Mass number is called number of proton plus number of neutron, because those are the heaviest particles in the nucleus in the atom. Therefore, the mass of the atom determined by number of proton and number of neutrons in the nucleus. So mass number is number of proton plus number of neutrons. So now what you can say about the isotopes? So what is the isotope then? If we are talking about the isotope, what is the isotope? So isotope is when the element have same atomic number and different mass number. Okay, same atomic number and different mass number. Same atomic number and different mass numbers. In other words, what you can say? So isotope, we consider atom as isotope when they have same number of protons and different number of neutrons. Okay, same number of protons and different number of neutrons. So when we consider these three isotopes, these are the isotopes of hydrogen, because atomic number is the same, therefore the element is hydrogen, but the mass number is different. In other words, number of neutrons available in the nucleus of each atom is different. For an example, first one, it has only one proton. I will come to the electron, number of electron later. Okay, don't worry about the electron at this moment. You just focused on number of neutron and proton. We are talking about the nucleus. So in the first atom, it has only one particle, one subatomic particle in the nucleus, which is proton. In the second atom, it has two subatomic particles in the nucleus. What are the subatomic particles in the nucleus? We have one proton and one neutron. We have one proton and one neutron. So total number is 2. That is why the mass number is 2. Then we have third atom. It has one proton, that is due to the atomic number, and two neutrons. Two neutrons, since the mass number is 3. Okay, so now you can identify that there are 3 isotopes of the hydrogen. The first isotope, we call it as a protium. So this is the hydrogen we're talking about. This is the hydrogen atom, what we are talking about in all the chemical reactions and all. Protium, where it has one proton and no neutron. There are no any neutrons. Why I say there are no any neutron? The mass number is equals to the number of protons plus number of neutrons. So mass number of the protium is 1. Number of protons in the protium is 1. Why number of protons? Because atomic number is 1. Therefore, what is the number of neutrons in the protium is 0. 0. There are no any neutrons in the protium. So this is the hydrogen atom, you know. There is another isotope of the hydrogen where it has two, where its mass number is 2. In other words, it has one proton, and one neutron. We call that isotope as deuterium. Okay, deuterium. Then tritium, since it is the same element, number of protons are the same, but it has two neutrons as as a result of that. We call this one as a tritium. So these are the isotopes. These are the isotopes. So as a homework, find out isotopes. Find out isotopes of, as a homework, find out isotopes of oxygen, isotopes of nitrogen, right? Isotopes of chlorine, right? As a homework, right? Just browse and try to find what are the isotopes of these elements. All right. All right, so now let's try to talk about the electron. So we consider isotopes based on the number of neutrons available in the nucleus. The atomic number is the same, but different mass numbers. Mass numbers are due to the various number of neutrons in the nucleus of the same element. So, electron, number of electrons. So what you can say, if I am going to add one more line to this one, which is the number of electrons. Number of electrons of the each atom. Number of electrons of the each atom. So what you can say, how many electrons you are going to put here, here, here. Can you fill the blank? Have you know how many electrons are there? So this is electrons. So I need you to think about number of electrons of the protium, number of electrons of the deuterium, number of electrons of the tritium. So what you can say, how many electrons are there? How many electrons are there? So what is the basis for that? What is the basis for that? Which is the charge of the atom? Which is the charge of the atom? Okay, charge of the atom. Again, charge of the atom, not the subatomic particle. It's very important. We talk about charge of subatomic particle. What is the charge of the electron? -1. What is the charge of the proton? +1. Everyone is following? So if you consider the protium, what is the overall charge of the atom? It has one electron with the -1 charge. It has one proton with +1 charge. So what is the net charge of the atom is 0. Why it is 0? +1, -1, 0. The charge of the protium is 0. Charge of the protein is 0. So if there is a charge on the atom, we indicate it here. So this is the mass number. This is the mass number. This is the atomic number. And here we are indicating the charge of the atom. In other words, overall charge of the atom, net charge of the atom. So When we are going to talk about this charge of each atom, so what is the number here? Is there any number indicating? No, there is no any number. In other words, if there is no number, which is called zero, which is called zero, okay, which is called zero. If there is no number, we call this one as zero. Again, when we are going to talk about atom, now we have discussed about the atomic number and isotopes. If you are going to figure out how many electrons are available in the atom, then you have to think about the charge of the atom. Okay, charge of the atom. So we have already discussed the charge of subatomic particles. Subatomic particles. Electrons are negative charge, protons are positive charge. When we consider the protium, it has one proton and one electron. Therefore, overall charge of the atom is zero because plus one cancels the minus one, zero. So when there is a charge on the atom, when there is a charge on the atom, we indicate it here. When there is a charge of the atom, we indicate it here. If there is no number indicating there, we call it as a zero. So if the charge is zero, if the charge is zero, what is the meaning of that? Number of protons of the nucleus is equals to the number of electrons around the nucleus, because protons are positive one, electron is negative one. If the overall charge, if overall charge of the atom, is zero, what is the meaning of that? Number of proton is equal to the number of electrons of the atom. So therefore, what you can say about the number of electron in each case? So we are going to talk about number of electrons in each atom. So there are three isotopes of hydrogen and we are going to determine number of electrons. So first one, is there any charge here? There is no any charge on the atom. Therefore, if the charge is zero, what you can say is when the charge is zero, right? When the charge is zero, number of proton is equals to the number of new electrons in the atoms. So therefore, the protium isotope has only one electron. Why is that? Because it has only one proton. If the overall charge is zero, it must have only one electron. Let's go to the deuterium. What is the charge here? Again, it is zero. Therefore, when the charge is zero, what is the meaning? Number of protons of the element is equal to the number of electrons. So therefore, we have same number of electrons in the deuterium as well. And the tritium also the same. I'm going to give this example. Very simple example. These are not huge atom. This is the this is the simplest atom in the periodic table, hydrogen. So you should be able to understand this. Okay, you should be able to understand it. Okay. So what I did, I wrote two atoms atomic number is 1, mass number is 1. So since the atomic number is 1, we are talking about the hydrogen. Since mass number is 1, we are talking about the same isotope. If I ask you to write number of electrons in each element, first one, what is the charge? First element, charge is 0, therefore it has a 1 electron. Why charge is 0? Number of electrons are equal to the number of protons. Number of protons and number of electrons are equals. Okay. In the second element, overall charge is the plus 1. So the charge of the element, how we calculate the charge of the element? Charge of the element is equals number of proton plus number of electrons. So charge of the element, right, is plus 1. Charge of the element is plus 1. Therefore, how many electrons are there? 0 electrons. So there are no electrons, right? So that is how you are going to figure out number of electrons. Okay, number of electrons. In this case, every isotope has same number of electrons because all the isotopes are neutral isotopes. All the isotopes are neutral isotopes. Right, so let's move into the next slide. Right, so shape of orbitals. So first of all, what is the orbital? What is an orbital? So as I mentioned, there are energy levels around the nucleus. There are energy levels around the nucleus. If this is the nucleus of the element, there are energy levels around the nucleus. So we call these energy levels, right? So inside these energy levels, we have orbitals. Inside of the energy levels, we have orbitals. In other words, this is the place where electrons are going to locate. Okay, around the energy level, in the energy levels, there are orbitals. Clear? So we can identify there are there are several types of orbital. So the simple orbital we have is called the s orbital. Then we can find p orbitals. We can find d orbitals, f orbitals. Okay, so what are the types of orbital? There are 4 types: s, p, d, f. There are 4 types of orbitals in the element. Okay, s, p, d, f. So these are the orbitals available in every element. Okay, so when we consider the shape of orbitals, s orbital is a spherical shape. S orbital is spherical. It is a sphere. Okay, it's like a ball, right? Think about the tennis ball or rubber ball. That is the shape of the s orbital. These are sphere. These are sphere. Okay, this in the 3D. You have to imagine this shape in 3D structure. This is not just the circle. It is a sphere. It's round object. In other words, best example is a rubber ball. Rubber ball. So that is the shape of S orbital. That is the shape of S orbital. So what is the meaning of this? The electrons, if there is an electron in the S orbital, so this is the place where electrons are going to locate. On the surface of the sphere, electrons are going to locate. Okay, in other words, on the surface of the rubber ball, that is the place where electron is going to locate. Not in the inside of the ball or outside, on the surface of the ball. So that is the S orbital. Then p orbitals, there are 3 p orbitals, px, py, pz. So this is based on their orientation. The p orbital is dumbbell shape. So if we analyze the availability of the electron, so electron is going to available in these areas. So there are 3 p orbitals. When the p orbital is oriented around the x-axis, we call it as px, y-axis py, z-axis pz, right? So there are d orbitals. So when we talk about d orbitals, we consider it as 2 dumbbells crossing each other. So how many s orbitals are there? Only one type of circle, therefore sphere. Therefore, only one type of s orbital is there. How many p orbitals are there? There are 3 types of p orbital: px, py, pz. Same way, when we analyze the d orbital, we can identify dxy, dyz, dxz, dx square minus y square, and dz square. So how many d orbitals are there? So only one s orbital, only 3 p orbitals, and how many d orbitals? So we have 1 s orbital, 3 p orbitals, we have 5 d orbitals. When we analyze the number of f orbitals, right, we can identify 7 f orbitals. 7 f orbitals. So these are the various types of orbitals in an atom. Okay, in an atom. So the electrons are going to locate on these orbitals. If there is an electron in atom, it is going to be available on either s orbital, p orbital, d orbital, or f orbital. Clear? So that is very important you to understand. Okay, so what you need to understand, around the nucleus, there are energy levels, right? These energy levels are defined by the quantum numbers. These energy levels are defined by quantum numbers. So we have principal quantum number, azimuthal quantum number, magnetic quantum number. There are various types of quantum numbers. Okay, there are various types of quantum number. So you guys should read about that. Okay, again as another assignment, read about quantum numbers. Read about quantum numbers. What are the quantum numbers you need to read? You read about the principal quantum number. You read about azimuthal quantum number. Then you read about magnetic quantum number. Okay, so there are quantum numbers. Then there is another quantum number is called spin quantum numbers. Clear? Right? So we have the nucleus. Around the nucleus, we have the energy levels. These energy levels are defined by the principal quantum number, right? So then inside the quantum number, inside the energy level, what you have the orbitals. Inside the energy levels, you have the orbitals. Inside the energy levels, you have the orbital. Clear? Right? So it's very important you to understand it. Okay? So talk about the quantum numbers. You need to read about quantum. So what are the quantum numbers you need to read? You read about the principal quantum number. Then angular momentum quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Right? So you need to read about this. So these are the numbers, these are the quantum numbers which determine the energy levels of every atom. So as I mentioned, we have a nucleus, that is the center of the atom. Then there are energy levels. There are energy levels. Whether we have 1 energy level, 2 energy level, 3 energy level is determined by the principal quantum number. If it is a 1, that is the first energy level. If it is 2, second energy level, third energy level, fourth energy level, likewise to the infinity. Energy levels. Then angular momentum quantum number or azimuthal quantum number, which determines the orbital. So if we have 0, that is s orbital. If we have 1, that is p orbital. If the number is 2, which is d orbital, number is 3, f orbital. Okay? So then the magnetic quantum numbers. So what are the magnetic quantum numbers? Whether you have px, py, pz. Okay? Right? Then the spin quantum number, which determine electrons up or down. This is the simple idea. So as a homework, you need to read about these quantum numbers. Okay? Read about these quantum numbers. Okay? You must be expert. You should be able to identify these quantum numbers, and because they are very important. Okay? They are very important. So read about the quantum numbers. What you need to understand here, I don't want you to learn quantum mechanics. That is not what I mean. I don't want you guys to learn the quantum chemistry, quantum mechanics. That is not what I mean. What I want you to study, what is the principal quantum number, what is the azimuthal quantum number, what is the magnetic quantum number, what is the spin quantum number, and how they are going to determine the features of the atom. That is what I want you guys to study. If you don't study, then you won't be able to identify, understand future things. Therefore, this is critical. Okay? Right. So let's move into the next slide. Next slide. Okay. So when we are going to talk about various types of elements, okay, various types of elements, we can identify the various number of electron in each element. Therefore, we should be able to identify and write the electronic configuration. In other words, how electrons are arranged in the element. Okay, so what is the electronic configuration? The simple meaning of the electronic configuration is how electrons are arranged in the atom. In other words, where these electrons are located on the atom. That is called the electronic configuration. Okay, so now we are going to talk about the electronic configuration, right? So again, it is very important you to read electronic configuration. Okay, so read about electronic configuration, and sorry, not the electronic configuration. I want you guys to read about what? Quantum numbers. Okay, quantum numbers. So read what is the principal quantum number, angular quantum number, or azimuthal quantum number, magnetic quantum number, and the spin quantum number. Then we are going to discuss about the electronic configuration. So this is the first part of the lecture. So second part we will start once you read the, once you educated yourself about the quantum numbers.